Powersploit is a PowerShell post-exploitation framework. And what this means is that Powersploit is used after the attacker has already obtained access to the victim's machine. Powersploit consists of a collection of penetration and security modules and functions that are written for PowerShell, which is Microsoft's task automation and configuration management framework. Powersploit is built on the .NET framework, which enables access to a vast collection of libraries. Powersploit was created by Matt Graber, who was a .NET developer. He created Powersploit for reverse engineering, forensic analysis, and penetration testing in the Windows environment, and he actually created it with the intent of using it independently of any other pen testing tools. He adapted existing scripts to work efficiently with PowerShell and packaged them into a utility called PowerSyringe. He later modularized PowerSyringe into 3 individual scripts and renamed it Powersploit. And Powersploit originally consisted of invoke DLL injection, invoke shellcode, and encrypt script, which are all now included in the code execution module within Powersploit. And so that brings us to, what is PowerShell? PowerShell is a Windows task automation and configuration management framework, and it consists of a command line shell and its own associated scripting language, which is built on the .NET framework. PowerShell provides full access to many libraries and enables admins to perform administrative tasks on both local and remote Windows systems. In PowerShell, tasks are performed by running commandlets, which are specialized .NET classes that implement particular operations. The commandlets use verb-noun commands. They follow that kind of structure, a verb followed by a noun. And so if you use getDate, so it gives you the current time and date, and it's a verb followed by a noun.
Powersploit consists of a wide variety of modules that can be used to attack many different aspects of an operating system. First, there's the antivirus bypass module, which allows the attacker to bypass any antiviruses by modifying the signatures of any binary files he's using. This allows Powersploit to enter undetected and run commands that would be otherwise blocked. Then there's the code execution module, which allows you to run a variety of scripts that have effects that range from injecting DLLs to causing blue screens. The exfiltration module is used to gather information from the attacked computer and copy it into a place where the attacker can get at it. Some examples of this are the get keystrokes and get timed screenshots, which allow the attacker to gain information as the user is using the compromised machine. Then there are things like ninja copy, which allow discrete copying of files that is virtually undetectable by the user. PE tools stands for portable executable, and it's a set of tools that is used to gather information when an executable is running. Some examples are getDLL path, which allows you to see what the path is of the DLL that an executable is running. In addition, there are things like getObjectDump and getLibrary symbols, which allows you to get more information about the running executable. The persistence module allows you to create a new script that would wrap around a script that you want to have occur multiple times on different events. Recon is a module that is used to gather information about the network. For example, we have things like getPortScan and getReverse DNS lookup, which will allow you to gain information about the IP addresses and the ports available on the network. Reverse engineering is a very complicated module that is used to basically disassemble a running executable and get many of the functions that are used within it. This module is primarily used as a way to take an executable, break it apart into its parts, and then try to figure out how it was developed. This is also very useful in the case of you trying to defeat an antivirus system, because it allows you to break it apart and then find out how it's actually doing its sensing, and then create scripts that will allow you to avoid getting sensed. Finally, we have the script modification module. This allows you to encrypt and decrypt scripts as well as allows for compression of DLLs. This is useful when you're trying to pass your scripts into the system and then unencrypt them to be able to use them properly. Quite a few of these modules can be used in tandem for additional benefit. For example, the PE tools and the reverse engineering module go well together since they allow you to gain a lot of information about what the executables and functions that are running on the system. Since this is quite a few modules for us to cover, we're going to be focusing on only a few of them in the following video. The ones that we're focusing on will be antivirus bypass, exfiltration, code execution, persistence, and recon. These modules show some of the main parts of Powersploit and how it will be useful for an attacker or a penetration tester. First, navigate to the Powersploit GitHub repository. Once you get to the repository, scroll down and download the zip file of the repository to your computer. Once you have the repository downloaded, unzip it in this folder. Then go into the folder and change the top level file name to Powersploit. So we just want to get rid of this master here because it will interfere with installation. Copy the folder and move it to a different directory where PowerShell can access it. Just paste it into the modules folder of the Windows PowerShell. You'll need administrator access to make this happen. Now, open up PowerShell as the administrator. Before we can install, we have to make sure that we are able to run scripts. To make sure of this, do set execution policy, and we want to set this option to unrestricted. This will let us run any script that we download or add to the PowerShell modules. Now we can install Powersploit. We use the command import-module and then the name of the module we're trying to install, which in this case will be Powersploit. We can see a list of the commands that have been installed with get command -module and the name of the module, in this case again, Powersploit. This is a list of all the commands that are available in Powersploit. If we want more specific help about a single command, we can use the get help command. It's get-help and then the name of the command that you want to look at. So in this case we'll use get help watch blue screen. And that will give you some advanced options about how to use watch blue screen or any other command that you want to look at. One of the commands available on Powersploit is invoke port scan. Invoke port scan is a command that can be used to get a scan of all ports available on a host. You can use it by calling invoke port scan and then give it the hosts option and then add in any hosts you want to scan. You can add one or more hosts. In this example, we'll be scanning google.com to see what ports are open and what ports are filtered on it. Once the scan is started, you have to wait a little while for the scan to be complete. Invoke port scan is actually loosely based on Nmap and is basically a port of that technology onto the PowerShell environment. Here we have the results of invoke port scan. As you can see, it will show the open ports 80 and 443 as well as the filtered ports that it has found. Invoke port scan can be a replacement for Nmap in certain cases. Usually, however, Nmap is the better utility since it has a lot more support and options available on it. There are certain cases where invoke port scan might be better for you though. For example, if you only have the Windows environment available, then a utility such as nmap may not be possible for you to use. Additionally, since Powersploit allows you to use a number of built-in functions such as antivirus bypassing, then if you're an attacker who has gained access to a user's machine, you may not want the user to know that you're running utilities such as nmap. In this case, a utility such as invoke port scan might be better. Another recon command available on Powersploit is invoke reverse DNS lookup. As the name implies, this is basically just a utility that will allow you to look up the name of given an IP address. I'll run an example using the IP address of the computer I'm using right now. If we look in command prompt, we can see that the IP address of this computer is 155.41.80.148. If we use the reverse DNS command, then we just enter invoke reverse DNS lookup 155.41.80.148. And this gives us the host name, which is mikhail-pc.bu.edu.
Find AV signature is a script that helps a pen tester slip malicious code into a system without alerting antivirus software that may exist on the machine. Now, before I explain the script, it's necessary to get some background information on antivirus software in general. A lot of antivirus software references databases that contain single byte signatures that are known to exist within malware. These types of antivirus software scan for malware by checking the binaries of portable executables like exe files that have been written to the hard disk. If some binary contains a byte that matches a known signature, then the antivirus will read the binary as a virus and alert the target user. So, in order to bypass these types of antivirus software, FindAV signature splits the binary into many smaller component files. By scanning the binary in small portions in an antivirus software, you can pinpoint the exact location of the virus's signature's byte. However, knowing the location of the virus's signature is not sufficient to evade detection. You will need a hex editor with which to alter the byte at the beginning. With FindAV signature, you can give a start byte and an end byte, so you don't necessarily have to scan the entire file. This helps for the subsequent rounds of FindAV signature after the first round. You can also select how many bytes you want to be in each file with the interval flag. So now we're going to run FindAV signature on the Sigwin setup exe file. So here we have the start byte is going to be just the first byte in the exe, and then the end byte is going to be just the maximum. And the exe is going to be cut up into 10 kilobyte increments. And the file is located in here. And let's see, just run this. Okay, and it's going to create 97 binary files. So now I'm going to go take a look at that folder. Okay, and here are all the binary files that it created, and there's 97 of them. Since that this file wasn't actually a virus, if we run it through an antivirus scanner, it's not actually going to come up with anything. And so I'm going to show some data from an example that was online for a similar utility to FindAV signature. And so here it is. So this particular example used Ice Gold Freezer, which is detected as a virus by a Vera antivirus. So those two things were used here. And when they ran the first instance, there were 234 bin files created, and the first 7 came out clean, and then the 8th through the 234th files came out as having a virus on them. Now for the second time, we'll run FindAV signature, and this time we're going to use just the 7K and the 8K files because one of them doesn't have the virus signature in it and the other does. So these will be the upper and lower bounds, and this brings us to our second run of find AV signature. And this time we're going to use 100 byte increments. We'll scan the new output files with Avira again, and this time it comes out that 7,000 and 7,100 are clean, and the rest of them are still listed as having the virus on them. So for the third run, we're going to use the last clean one and the first dirty one. And so that gives us a range of 7,100 to 7,200. And this time we're just going to use 10 byte increments, and so we're just going to have 10 files. And so here only the first one turns out clean, and then the rest of them are still listed as having the virus on them when they're put through Avira. So for the fourth run, each file is going to just be 1 byte wide. And now we can clearly see that for 7100 all the way through to 7107, these ones turn out clean when passed through Avira, and 7108 and 7109 are listed as having the virus. So now we know that 7108 is exactly where the signature for the virus starts. So after you've pinpointed the location of the virus's signature, you can use a hex editor to change that byte. Then you can recombine all the bin files, and the new exe will pass through Avira antivirus undetected.
In order to use the screen capture module, type get time screenshots -path followed by the location where you want to save your screen captures. In this case, I'll be saving them onto my desktop. Next, specify your capture interval with -interval, followed by your interval in seconds. And lastly, provide an end time. We can see that once the module is running, the screen captures are showing up on my desktop, and the preview icons reflect the current state of the desktop. This module accomplishes this by using the libraries available in the .NET framework, specifically the bitmap class. The getTimeScreenshots module is ruled by a do-while loop. Essentially, as long as the current time is less than the end time that was specified by the user, the screenshots will be taken regularly based on the interval that was set. The keystrokes module logs the keystrokes of the victim, as the name implies. The proper syntax of this module is as follows. Get keystrokes -log path, which is the path of the folder that you'll be saving your log to. I will be saving it onto my desktop again, and it will be called videokey.log. The next parameter and the last parameter is collection interval. This specifies how long you will be running this module in minutes. I will be logging keystrokes for 5 minutes. Similar to get time screenshots, once the module is ran, videokey.log is created on my desktop. If we take a look at the contents of the log immediately, we'll see that it has logged some mouse clicks. That is because I had to use my mouse in order to open the file. Now what we can do is go to a new text document and write a test string such as hello. I am testing the module. Now we can reload the log and see the updated contents of the log. What we should also notice is that the module also logs the window title where the key or mouse clicks are triggered. For instance, I had typed the letter E at this time in Notepad++. What I'm demonstrating here is merely typing into a text document and then retrieving the text typed from the log file. However, imagine if we were to run this module while someone is accessing their online bank accounts or even buying items where they need to input their credit card credentials. The significance and impact of this module increases dramatically when we take this into account. Looking at the contents of the log file, we should notice that it is in CSV format, which means that we can import this into Excel. To do so, simply open Excel, navigate to the log file and open it. Once we try to open it, Excel will provide a wizard for us. We choose delimited as the option, we choose comma as a delimiter, and we leave the text qualifier as quotation. After this, we hit finish. As we can see, Excel will categorize the 3 fields into 3 separate columns, making it much easier for us to read. Looking at the newly formatted data that we have obtained, we should see one flaw. Sometimes the module will record multiple key presses. For instance, if you remember, I had originally typed I am testing the module. In the word testing, the letter I was registered 3 times. This is due to the way that the module was coded. The get keystrokes module is set to conduct a sweep every 40 milliseconds. Most computer users type at a frequency much slower than this. As a result, the module will record multiple key presses, even though it was only pressed once. This is actually a place where this module can be improved upon. The sweep module can be changed into one of the parameters that needs to be specified by the attacker. In this scenario, the attacker can perform some social engineering in order to obtain an estimate on the typing speed of the victim. Upon obtaining the typing speed, the attacker will be able to adjust this module accordingly to improve its effectiveness.
Another module you can use for exfiltration is invoke ninja copy. To use this module, you first type invoke ninja copy, then -path, followed by the hard path of the file you want to copy. Then type local destination, followed by the destination you want the copy to be in. So first I have a file in my target folder, and it's called test. This is the contents of test. Then my local destination, and this is where I'm going to be saving the copy of test, is copy.txt, and it's empty. So when I run this, alright, so ninja copy is finished, and I'm reloading copy.txt, and it has all of your secrets in it. As you can see, this module is able to copy files. However, there's much more to ninja copy than just copying a file. It's able to copy the file without leaving any kind of footprint. This includes system files. Normally, there are 3 important factors that must be taken into account when a system file is accessed. Ninja copy is able to bypass all 3. The first is that certain files like NTDS or one of the registry hives can't be accessed as long as another process has hold of it. In other words, as long as a system process is accessing that file, it can't be opened by anything else. Second, whenever a system file is accessed, the SACL, or System Access Control List flag, is triggered. This is not the case when ninja copy accesses a system file. Finally, the DACL, or Discretionary Access Control List, enforces that only processes with system privileges can access system files. So ninja copy is able to bypass all 3 of these because of the way it works. And basically, it copies the raw NTFS structures and parses it for the information it needs. That way, it's able to bypass the 3 characteristics mentioned before.
Some of the most potent options allowed by Powersploit are in the domain of code execution. What this module entails is running predefined or given scripts through the PowerShell framework. One large portion of this module is with injection. In particular, the module inject login credentials allows you to create a new user with a domain and login credentials, which will allow you to impersonate a user on the system. In particular, Powersploit does this without triggering security flags, allowing for discrete penetration. The backbone of this command involves creating a new winlogon.exe process, and then using a more general tool called invoke DLL injection to inject a DLL that calls LSA logon user and creates a new logon. This creates a new set of logon credentials that an attacker can use to elevate their attack. Another module that is used is add persistence. The add persistence command allows you to take a script and make it run repeatedly at a certain time or after a certain event. This can be very useful for both attacking a system and defending it. When properly called, add persistence creates two scripts, one to invoke the persistence and one to delete it. This gives you easy control over controlling the script operation. Before we can run add persistence, we will have to set up a variable or a script that will be able to be passed to the function. In this case, I will set up a variable, rickroll, which will open up an Internet Explorer shell that will send content into the PowerShell terminal and display some ASCII characters. Although in this example I'm setting up a variable that will run a command, you can also just pass a script that has already been written to disk. Before we can call the add persistence function, we have to set up a few variables that will be used by add persistence. What this variable does is that it sets up the condition on which we want the script to fire. This variable sets up some user options that are used by add persistence to allow the script to fire under a user. Finally, we call the add persistence command. We pass it the variable that we created, set the elevated persistence options, set the user persistence options, we want to call the verbose flag to see what's happening, and some other flags to make sure that the script is created correctly. Finally, we set the file to which we want this new persistence script to go to. As we can see, the file has been written to disk. We can now take a look at what add persistence has created for us. If we look at the persistence script with the PowerShell ISE, we'll be able to see the exact commands that are being used to make sure that the persistence is active. You'll notice that in addition to creating the persistence script, the function has also created a remove persistence script, which will allow us to stop the persistence after we've decided that the script has finished its purpose. The final command that it will show in the code execution module is the watch blue screen. This basically causes a blue screen in a Windows 7 computer. It does this by creating a new object with a set of parameters that will cause the Windows 7 to blue screen. When the commandlet is run, the object is created and called, causing a blue screen to occur. We can now see it by typing in the watch blue screen command. As can be seen, the virtual machine has caused a blue screen, causing the VM to shrink. That concludes our overview of Powersploit. As we have shown, Powersploit is a suite of tools that can be used to penetration test a wide variety of aspects of an operating system. It is useful for gathering information, grabbing key data files or passwords, escalating a user's account access, and destroying the usability of the system. Further, it contains the ability to evade an antivirus program. Powersploit can also be used in tandem with other tools. For example, it can be used with Metasploit to gain access to a poorly defended system and steal vital information. For a penetration tester whose goal is to defend a system, Powersploit gives a good way to test if a system is secure from within. I hope you enjoyed our video. Thank you. Now, open up PowerShell as the administrator.